Hi there. So now that you've gone through and shown how to simplify radicals without variables, now we're going to include variables inside of our radicals. So our big question here is, how do we simplify something that looks like this? We have square root of x to the 7th. You've gone through all your rules with numbers, so now our focus is on the variables. Well, let's take a look at a couple of examples and let's see if we can identify what the pattern is. If I took the square root of x, which is technically x to the first power, my answer would just be the square root of that x. But once I increase to the square root of x squared, there are two of them in there, I get the answer of x. When I increase to x to the third power, it's essentially these two put together. So I can take one x out, but one of the x's is going to end up being left over. If I take square root of x to the fourth, I get x squared. So now when I increase to a 5, I have an x squared on the outside, and I have a leftover x on the inside. And then finally, if I have the square root of x to the 6th, I have x to the 3rd. So the big question is here, what is the answer to the square root of x to the 7th? Well, essentially, I know that their x to the 6th that's in there, because there are 6 of them, will become x to the 3rd, and I will have 1 left over. So square root of x to the 7th is x to the 3rd times the square root of x. So I hope you're noticing a pattern here. Let's look at the even ones to see if you can find it. 2 becomes 1, 4 becomes 2, and 6 becomes 3. In general, you're going to divide the exponent by 2 because you're taking the square root, and that means you're going to divide that exponent by 2. Now sometimes there's an odd number, which means we have a remainder. The remainder stays inside the radical. So perfect squares are allowed to come out, and the leftovers stay inside. So here's a couple of exponent rules we've already gone through. We're going to apply some of these just now. So let's just review that. We have the product rule. The product tells us that we're going to add the exponents. So x to the 6th times x to the 3rd equals x to the 9th, because we take 6 plus 3 and we get 9. The quotient rule, however, tells us to subtract the exponents. So if I have a quotient or a fraction such as x to the 7th over x to the 4th, 7 minus 4 gives us x to the 3rd power. If we have a negative exponent, we're going to change to the opposite side of a fraction bar. So for example, if I have x to the negative 3 in the denominator, it's going to move to the numerator and become positive. Or if I have something such as x to the negative 2 in the numerator, I'm going to move it into the denominator. So this is our final rule we're going to learn, which is when we take the square root of variables, we divide it by 2, and any remainder is kept inside the radical. So let's take a look at a couple of examples. We're always going to simplify. I'm going to do this one step at a time, meaning one variable at a time. You don't have to do that. You can do it all at one time, but for the sake of going through the notes and explanation, I'm going to do it one at a time. So let's start with our x values. I see I have x to the 9th. So what I'm going to do is do 9 divided by 2, and the biggest number I get is 4. So I have x to the 4th on the outside, but I have a remainder of 1 because it is odd. So what I see is I can take x to the 4th out after I've divided it by 2, and then I have a single x left over because that was an odd number. So then I'm going to move on to my y and repeat the same process. If I take 4 and divide it by 2, I end up with y squared. Since it was an even number, I don't have anything left over. There's no remainder. Finally, with the z's, 11 divided by 2, the biggest whole number would be 10. So on the outside, we would do 11 divided by 2, the biggest whole number we would get is 5. Sorry about that. Which means we have a leftover of 1z. And so this would be our simplified radical. Now one little note here is, since we are dividing by 2, there should not be an exponent that's higher than 1 in a radical. So if either of these had like an exponent of 3 or 2, which means we did not take out as much as we possibly could, and it is not simplified as far as possible. Let's take a look at our next example. So we're going to simplify something that looks like this. We have a number on the inside. So what we're going to do is apply the rules that we had from our previous lesson. Well, the square root of 25, 25 is the biggest perfect square that goes into 25. So I'm going to look at the numbers first. The square root of 25 is 5. So that's the number that's going to go on the outside of the radical. Now, one at a time, I'm going to look at my variables. X to the 5th, if I do 5 divided by 2, my biggest number is going to be 4, and I have a remainder of 1. So 4 divided by 2 gave us 2, so we have x squared, and I have a single x left over. Now the z only has a single z in there. so I can't take any more z's out. Once I'm down to only a single exponent, you can't take anything out. And this would be your simplified radical. One last example. Now don't be intimidated by the size of this, it's just the exact same thing. However, we have to keep in mind that we have these numbers on the outside and variables. And remember, this is one big multiplication problem. So what we're going to have to do is bring in our properties of exponents when we involve a product. Well, the first thing I'm going to do is work with this 27. So thinking back, this is a little bit of side work. The square root of 27 you just learned. The biggest perfect square that divides into 27 is 9. Specifically, this is 9 times 3. And remember, when we find our perfect square, we're going to put a square around it. The square root of 9 comes out and becomes 3, and then leftover 3 is on the inside. So on the problem we're doing now, it's going to be 4 times the 3 we just take out, and that leftover 3 is on the inside. So now I'm going to work through my other variables. When I see m to the 4th, I see that I'm going to 4 divided by 2 is 2. So I have an m squared, but I had another m already out there. So I'm kind of putting those together. I have an n squared, 7 divided by 2. 7 divided by 2 would give me a 3, not the 6 that was there. Give me a 3 here, but I have an extra remainder of 1. And so that way there's an n left over. 2 divided by 2 is 1. So this is what I now have on the outside when I simplified. Now 4 times 3 gave me 12. That's where that 12 comes from. This is the original m squared came out. This is the original n squared, n to the third came out, and then I have a p. So thinking to those rules of exponents that we just talked about, when I have a product, what do I do with those exponents? Well, I add them together. 1 plus 2 gives me 3. 2 plus 3 gives me 5. P didn't have anybody to combine with, so it's going to be left alone. 3 to the n is on the inside, because that was what was left over. Why don't you go ahead and try some of these on your own? Do the best that you can. That's all we're asking for. All right, check your answers and see how you did. If you have any questions, make sure you're asking your teacher. Go ahead and get started on the practice.